Okay, so hope everybody's doing well. POM students, this is day 8. Changed colors a little bit, some purple action going on here, and this will hopefully be viewed either Monday, March 23rd, or most likely Tuesday, March 24th. So this will be the day that we'll assess on simplifying radicals. So I just want to go over some problems that are in these do now slides, these two you see right here. And then I'm going to put up maybe 3 or 4 problems of my own that hopefully will give you some help for the assessment. So as I'm looking at this first one, I see 2 root 12 minus 3 root 12. Now, again, maybe it makes sense, and if you want to write this off to the side, you can, but just some general steps. Whoops, this isn't going. Sorry. You're seeing corrections made in real time here. Okay, steps. Number 1, especially since we've introduced dividing radicals, we want to make sure we reduce, or you could call it simplify, whatever you like, reduce or simplify inside the radical. What do I mean by this? Well, if I had radical, let's just say 8 over radical 2, I could write that as radical 8 over 2, which is radical 4, which is then 2. So you don't need to simplify the actual radical first. If you make a fraction that then can be reduced, you can, that's just an easier way to go about it. So think about inside when we have fractions, reduce or simplify inside the radical. Number 2, after we've done all that, then we make sure that we simplify radicals. And then the other term that we have learned, whether we need to rationalize if there's one radical in the denominator, or conjugate if there's 2 terms and one of them is a radical, we can do that. So I think having these 3 steps may help you. Maybe write that down in your notes if you want to hit pause. But the steps, just make sure whenever we see a radical in the numerator, like we did here, numerator and denominator, see if that fraction, 8 over 2, can be reduced, and maybe make it easy on yourself. Then worrying about simplifying radicals, and then making sure we don't have anything in the denominator. So with that said, let's quickly run over a few of these problems. I notice, before even combining this first one, that root 12 can be simplified. Okay, so I know that root 12 is 2 root 3. It's 2 times 2 times 3. So the 2 goes there, 3 goes there, it was underlined. And I've seen that enough so that I could rewrite this problem as 2 times 2 root 3 minus 3 times 2 root 3. So all I've done is replace root 12 with a simplified radical. Now outside times outside is 4 root 3 here minus 6 root 3. And now my radicals are simplified. And I can combine the coefficients and get negative 2, because that's 4 minus 6, radical 3. Okay. If you combined at the beginning and just did 2 minus 3, you'd have negative radical 12, which again would be negative 2 radical 3. So definitely more than one way to do it, but that's how I would look at the first one. At the second one, I notice that root 10 and root 3 are simplified. Okay, so I see an expression inside my parentheses, and I'm going to have to use the distribution property. Okay, so 2 root 3 times this term, if I think outside times outside, 2 times 5 gives me 10. Inside times inside, the 3 times the 10 gives me 30. Minus this term times this term. Outside times outside gives me 14. The 2 times the 7. Inside times inside, well, root 3 times root 3 is just 3. So I have 10 root 30 minus 42 is 14 times 3. Okay, so in the last few minutes for today, this will be hopefully a shorter lesson. I just want to put up a couple of example problems to get you to kind of think of it. And I'll probably do maybe 4 or 5. So the first one, again, these are something that might show up on the assessment, would be something like opposite radical 28 x to the 5th. Okay, and so I'm looking at this number right here. Simplify that, I'd get 4 times 7, and this is 2 times 2, circle, underline. We have a lot of practice doing these. 28 is the same as 2 times 2 times 7, so 2 comes outside, I have a 2 outside, 7 stays inside, it's actually a negative 2. And then I'm looking at my variable. Well, I see x to the 5th. Remember, that's x times x times x times x times x. Circle 2 of them. Those 2 come out, x squared. This one stays in x. Again, that odd exponent means that I will have a variable left inside. So my final answer, again, negative 2x squared root 7x. Again, if you want to hit pause or watch it again, if you'd like to, that's fine. I'm going to scroll down here and do another one that's maybe something like this. So the first one was just pure simplifying. This is going to be combining radicals. What if we had, again, maybe 5 root 18 minus 2 root 18? Well, I know off to the side, root 18, let's simplify that first, is 3 root 2, because this is 3 times 2. Okay. So now I'm going to go back in here and put that in there. 5 times 3 root 2 minus 2 times 3 root 2. Outside times outside gives me 15 root 2. There's no inside number here. And then outside times outside here is minus 6 root 2. My radicals are simplified. I can combine my coefficients. 15 minus 6 is 9 root 2. Okay. Here's another example. I'm going to insert a blank page. You might see something like this, where we have maybe 12 times root 10 over 6 times root 10. Okay. A couple ways to think about this, but what I notice is that, first of all, my radicals are simplified, but I could also write this as 12 over 6. I can put them under the same radical. 10 divided by 10 is 1. So this is 12 over 6 times the square root of 1. But that's just 12 over 6. Again, my outside numbers have stayed the same, times 1. So I'm left with 12 over 6, which is 2. Okay, so going back here, my coefficients reduce to 2, and root 10 over root 10 is just 1. So that's 2. Okay, a couple of different ways to do it. Save yourself some time. You don't need to create more work if you don't have to. Another example of something like that might be radical 36 over radical 18. Put them under the same radical. 36 over 18 is just the square root of 2. Something like that. And then the last one, I do want to do an example of a conjugating before I stop. So I might have something like radical 3 over 5 plus root 2. I notice my radicals are simplified. Root 3, root 2, those are simplified. Okay, but this root 2, since there's 2 terms in my denominator, I can't just multiply by root 2. I need to multiply by the conjugate, which is this term with the same numbers, 5 and root 2, but just changing the sign. So I wrote it down in the denominator, got to write it on the numerator. My new denominator, remember when I FOIL this out, when we conjugate, we FOIL, but there's a shortcut. It's my first times my first, which is 25, minus, always minus, because I have a positive times a negative. When I multiplied my last terms, root 2 times root 2 is 2. So I'm going to get a 23 in my denominator. Remember, what happened to the outside and the inside? Well, I had 5 times negative root 2 gives me negative 5 root 2. My inside here, 5 times the positive root 2 gave me positive 5 root 2. So those cancel out. And then I have to distribute up here. Root 3 times this, root 3 times that. Root 3 times 5 equals 5 root 3. Root 3 times root 2 is root 6. So my final answer is 5 root 3 minus root 6 in my numerator and 23 in my denominator. And that's going to be it for right now. So again, if you want to re-watch this video before you take the assessment, that's fine. We've done examples of every type of problem that you might want, but just think about these rules. Always reduce or simplify inside the radical when you see a fraction. Then simplify the radicals at the end, and then make sure once you've done all of that, that there's no radicals left in your denominator. If there is, you might have to rationalize if there's just one term, or you might have to conjugate if there are 2 terms in the denominator. All right, good luck, everybody, and we will see you on Thursday, as tomorrow, Wednesday the 25th, is a work day.